Just to put some details on statistical analysis of the large-scale signals of El Nino and La Nina. We had looked way back in chapter 7 how the heating and the emanating waves are communicating to higher latitudes, and how the extratropical tropical connections happen. So we were talking about waves, the background stretching information, and the basic state flow that's going to send signals from the tropics to extratropics. The mean flow was the divergent flow in the upper level because of the Hadley cell, and there were also eddy fluxes which gave us the strong westerly jet in the extratropics. So obviously the variability associated with El Nino and La Nina are similar processes because they are also changing the basic state, they are moving the heat sources, they are emanating waves which are going to go to high latitudes and also in the zonal direction and reaching faraway places, not just the tropical Pacific. Many analyses have been done of this. There is the Roplowski and Halpert analysis, which is considered kind of seminal. It was one of the first ones to appear in great detail using all the data at that point. Right now we have much more data and many more details have been put in. But essentially you are looking at colors where the percentile anomalies created by El Nino are being shown for different periods. So June to November of year 0, so when the El Nino is happening, June to September, September of 0 to March of the following year, and so on and so forth. And there are regions which are wetter when El Nino comes. So if you just look a little bit carefully here, for example, the seasonality here, or the Sri Lanka and Peninsular India region is during July to October, and here it's during June to September. So you are looking at the temperature and precipitation signals. So correlations of rainfall with extremes of ENSO. White contours represent anomalies in rainfall, dashed above average and solid below average. So above average rainfall and below average rainfall, above average rainfall, below average rainfall. Okay, that's important to remember because not every place gets dry. Rainfall redistribution happens. The letters denote the periods within ENSO years where the anomalies are maximized. Uppercase correspond to dry anomalies and lowercase to wet anomalies. So dry and wetter, and warm and drier. Okay, typically that's how it tends to go. Okay, what else? These contours are superimposed on the background El Nino minus La Nina composite. So these are taking years where La Nina related anomalies exist and El Nino related anomalies exist. You take their difference, so you get a complete range of the difference from an El Nino year to a La Nina year, and not just compared to the normal year to El Nino or La Nina. Okay, these are normalized precipitations, satellite determined OLR, cold colors denote rainfall deficits, and warm colors excesses. The satellite data matches in the details. So cold colors are rainfall deficits, and warm colors are rainfall excesses. Okay, which I hope is consistent with what we said here. White contours represent anomalies of rainfall above average and below average. So I hope it's all consistent. Anyway, you can see somewhat of wave patterns here going this way and so on, which we will look a little bit more into, but you can see how higher and lower rainfall anomalies occur in the regions. So if you can imagine the ITCZ and monsoon circulation, you are going to affect East African rainfall as well as Indian rainfall and Asian rainfall and maritime continent and Australian rainfall. The anomalies of temperature correspond pretty much to these and these horseshoe pattern here, and the extension of the temperature and rainfall signals along those lines as well. Essentially, it tells you that if we look carefully, there are also anomalies all the way in the polar latitudes. So the El Nino does have real global influence, and those are the large-scale influences. If you look at the mean DJF and JJA 200 hectopascal zonal velocity components for El Nino and La Nina, and the differences between the two ENSO extremes using these El Nino years, then you can see what we had seen before. So you have in DJF the upper tropospheric trough and the westerly duct, and that is modified by the so these are zonal flows modified by El Nino and La Nina. So you can see La Nina, you expect stronger trade winds, stronger upwelling, and stronger westerly duct in the upper atmosphere in DJF and also in JJA. So this is mean La Nina, and this is for JJ, and this is for DJF. So the difference of El Nino minus La Nina, you can see that our entire tropical extratropical connection is going to be seriously affected by the upper level wind anomalies associated with the El Nino and the La Nina during both the summer and winter season, which means the tropical extratropical exchanges are going to be affected by the El Nino related movements of the heat source and the circulation changes. Okay. We will just add a little bit here that the recent discussions have now grown around different patterns of El Nino. So far we have been saying El Nino and La Nina without saying where the warming happens. I alluded that maybe it doesn't happen always at the same place. So these are looking at different El Ninos, and you can see, without going into which one is which, there are many El Ninos which have a warming in the east central Pacific, with some having much stronger coastal warming, whereas some have warming in the central western Pacific with hardly any warming, in fact still colder anomalies in the east, and this one is much more loaded on this side with a negative anomaly on the equator here, and this one seems to extend from the subtropics into the tropics. In fact, there is a large literature on something called the meridional mode, which is a pattern that looks somewhat like this. So essentially, if you look at different El Ninos in various ways, so this is looking at EP and CP El Ninos, so East Pacific El Ninos and Central Pacific El Ninos. They are extracted using either directly the SST anomalies or using regressions of EOF of the SST anomalies, and take the time series and regress them against the SST anomalies and so on. These are now called Central Pacific El Ninos or dateline El Ninos, or there is another name called El Nino Modoki, which in Japanese means the same but not quite the same, or some such thing. But the debate continues about whether these are really distinct events, distinct in processes, or essentially the same thing with slightly differing patterns of warming and cooling. So that debate is not quite complete yet, but we will leave it there and touch on it just a little bit more when we come to recharge and discharge, which we haven't completely defined yet. But we will first look at some ENSO theories. Theories means multiple theories, which means there is not just one theory, which means we don't completely have a fully accepted single theory. That's something to remember. This happens a lot for things like Madden-Julian oscillation as well, which we will come back to later on. So despite having so much data, so much knowledge, so much understanding of the basics, there are some pieces of the El Nino that still remain to be explained, and these theories try to explain some of it, and even